So amines can act as bases. Remember, a base we define as a proton acceptor. So amines are bases because they have a lone pair of electrons, which you can see right here. So that's going to be the important characteristic of amines, which allow them to act as bases. So that lone pair is going to bond to a proton that comes in. So in the example shown here, the amine would be the base. This water molecule here would serve as the acid. So, right, that water molecule would be donating the proton. So the products would be what we call the ammonium ion here, which is going to have a positive charge, because remember, the amine over here is going to be neutral, right? It's neutral because there's no charge there. Whenever it gains the proton, it gains that positive charge, and that's what we have there in the ammonium ion. And then the other product would be the OH minus. So this is an acid-base reaction that can occur with a primary, a secondary, or tertiary amine. It doesn't matter if we were to have extra carbon groups here or over here. It would still work the same. And amines, whenever they're bases, they're considered weak bases. So remember, weak base means it's only going to partially, compared to like a strong acid, is going to completely dissociate. A strong base completely dissociates. Weak acids and weak bases only partly dissociate in solution. So in other words, if you were to look at a solution with an amine, most of it would be in this form here, and only a little bit would be in that form there, and that's kind of indicated by that reaction arrow you see there, which kind of points more towards the left. All right, so amines are going to react with acids because, again, amines are bases, so they're going to react with acids. And the product for that's going to give you a conjugate acid. So the amine is going to form the conjugate acid, and then the acid here is going to form your conjugate base. So again, very similar, or pretty much identical to what we talked about back in chapter 8 with conjugate acids and bases, except here sometimes the structures can be a little bit more involved. And you can look at the tertiary amine that we see over here, right? Tertiary because there's three different bonds between carbons and nitrogens there, but it doesn't affect at all what's going on. And then notice the proton that gets added is added up here, and then you also get the positive charge right there in your conjugate acid. And the acid, whenever it forms a conjugate base, gets a negative charge. When an amine reacts with an acid, the product we refer to as an ammonium salt. So the ammonium salt is kind of important in many cases because one thing we've talked about before, that salts are always water soluble. So salts are going to be water soluble. So we looked at an example like this with carboxylic acid as well, whenever we can take a carboxylic acid that would typically be insoluble and form a salt that would be water soluble. And the same thing happens here with many many amines that form the ammonium salts. So in this reaction, we have the amine over here. So this is your amine. This is going to be your base. HCl is going to be the acid, and then you're going to form the salt, which again, a salt is a mixture of the cation, which would be the kind of the carbon containing part, the carbon and nitrogen part. So all of this here would be your cation, and then the chloride would be the anion. And this is what I was just talking about on the previous slide about taking something that's water insoluble and making it soluble by converting it into a salt like this. And this is common in a lot of medicines. Benadryl is one that comes to mind. So diphenhydramine, right? Notice the name of that. I'll write it out. Diphenhydramine. That's the active ingredient in Benadryl. And whenever you have the diphenhydramine, it's actually water insoluble. But what you will usually see if you look at a bottle of Benadryl or the generic versions, they're called diphenhydramine hydrochloride. Well, guess what? That's the reaction with diphenhydramine with HCl to form a salt. which is going to be water soluble, right? And that's important whenever you ingest it because you want it to be soluble to go be able to travel through your bloodstream and to get where you want it to go to relieve your allergies. All right, so, here it is on the slide, right? So there's your diphenhydramine plus HCl to form the Benadryl. So again, very important property for many different types of drugs. It's not just Benadryl that's like this, it's a whole lot of them.